In this video, we will be covering factors in R. Factors are objects that take values with respect to a discrete set of fixed values or categories, like say the make or model of a vehicle. And these are particularly useful because when we convert a vector of data to be of type factor, R internally creates a mapping of the unique set of values in the past data to a set of IDs or integers that will be used in place of the original data. Typically, these IDs require much less memory than the original data, and use of the IDs can allow for certain types of operations to be performed much more efficiently, like, say, searching, for instance. For example, let's say I had a vector of data that contained the yes-no responses of some online query. So for this, I'm going to create a variable responses, and I'm going to assign it the values from our online query, and I'll simply print those out. While the example vector here is small and manageable, in reality, a vector like this may consist of thousands or more entries. But regardless of the number of entries itself, the data consists of only two possible responses, yes and no, which is perfect for factors. We can create our factor version of this data using the factor function. So I'll create a new variable, responses factor, and assign it the factor built from our responses data. And now if we look at the output, we see that we no longer have a vector of strings, and there's a levels attribute that shows the set of factors or categories that the data may actually use. In fact, we can verify that these values have indeed been replaced in our data using the asInteger function. This function will actually convert the type of the elements of the past vector to an integer representation, which in this case is the integral IDs for the factors. You see that the strings containing yes were replaced with the index 2, and those with no's were replaced with index 1. When using the factors function, it's going to actually sort the factors that it finds automatically. This is the reason that no came before yes in its sorting, and we got index 1 for no and index 2 for yes. So if the order of the factors is important to you, you can actually specify this with a combination of the levels argument and the ordered argument for the factors function. Alternatively, you can use the ordered function itself. Now, in this example, we allowed the factors function to discover the set of factors from the data itself. But it may be that we have a specific set of factors in mind for the data. The levels argument allows us to specify those factors, and the labels argument allows us to give each of those levels a separate label, which need not be unique. And this is nice because let's say our yes-no data contain not only the strings yes and no, but maybe also lowercase y and lowercase n. So I'm actually going to repeat what we've done before. We're replacing the responses variables with a new version of the data that does contain the lowercase y and n for a subset of the responses. And then I'm going to repeat the creation of the factors using these new responses, but I'm going to add the levels and labels arguments this time. And the reason we're doing this is when you go to use this data, you will likely only care that a given response was yes or that it was no, and not so much how they specified yes or how they specified no. So for the levels argument, I'm going to specify yes, y, no, and n in that order. And then for the labels argument, I'm going to specify the labels that I want each of those levels to have. So in this case, I want them to all have capital Y for any yes response and capital N for any no response. And now when we print the responses factor, we see that our data was replaced with all Y's and N's, regardless of whether it was a yes or a Y response, or a no or an N response. And you see here the levels are Y and N. So the factors function automatically condensed our levels and labels down to two unique values and use those values in our data. And just to prove to you that the factors function used our labels to reduce the number of levels from 4 to 2, we will output the integer representation of our responses factor. And we see here that indeed we get only 1s and 2s, no 3s and 4s. Also notice that the yes responses are now 1 and the no's are now 2. And this is because the factors function respects the order in which the labels were given. So to wrap up this notebook, I'm going to give you a quick example on how we can actually use these factors once they've been created. In this example, let us assume that in addition to these yes-no responses, we were also given the age of the individuals giving these responses. So now to use this data, I'm going to use a function from the apply family, namely tapply. And we'll cover these functions in a later section. But for now, tapply is going to use our factors to group data from another input vector, like our ages vector here, and then it's going to apply a function that we give it to each of the groups that it finds in the data. So more concretely, let's say that we wanted to know the average age of the person responding yes to our query, as well as the average age of the person responding no. We would write tapply, and then we're going to pass the ages vector, followed by our factors, which tapply will use to group them. And then finally, we're going to pass the function that we want to apply to each of those groups, namely the mean function, right? We want to get the average. And when we run this code block, we see that we get yes 23 and no 36.5. And if we were to go through the data, we would see that of those people who replied yes, the average age is indeed 23. And of those people that replied no, the average age was 36 and a half.